Let's see now far point and near point. We'll understand what is the meaning of far point and near point. Far point, the definition is the furthest point up to which an eye can see clearly without any strain is called far point of the eye. That means the eye is able to see any distant object clearly without any strain, so that distant object or the distance of that object from the eye is called far point. Okay, and for a healthy human being or healthy normal eye, this will be infinity. This will be infinity. Okay, but the far point can be changed for the other person, those who are having some disease, some eye disease, depends on their type of disease. That can be more than infinity, that can be less than infinity, whatever it is. Okay, obviously it can be less than infinity. Okay, and you will see now near point. The closest or the nearest point up to which an eye can see clearly is called the near point of the eye. The near point for a healthy eye of an adult lies about 25 centimeter from the eye. That means the eye is able to see any closest object very clearly without any strain. So that point is called near point. And for the healthy human eye, that is 25 centimeter. But the person, those who are having any disease, the near point can be changed here for that person, and that may be more than 25 centimeter. Okay, so this way it is far point and near point, the definition you may know now. Okay, the question is given here in the page number 190. What is far point and near point of the human eye with normal vision? So our answer will be the far point is infinity and the near point is up to 25 centimeter from the eye for a normal human eye. Least distance of distinct vision, LDDV. Here the minimum distance up to which an eye can see clearly without any strain is called the least distance of the distinct vision, is thus equal to the distance between the eye and its near point. For a normal eye of an adult, the least distance of distinct vision is about 25 centimeter. This distance usually increases with age. Look at here, when we are defining the least distance of distinct vision, we are telling it this is the distance. What it is? This is the distance up to which, the minimum distance up to which a healthy human eye can see. So here you may confuse between the near point and the least distance of distinct vision. I'm just clearing this point to you. Actually the near point when we are talking. Okay, so what happened, this is the eye, and from the eye the minimum distance is this much. Okay, so this much distance is what? Up to 25 centimeter, and this length of 25 centimeter is called the least distance of distinct vision, and it is denoted by the letter D. But this point is called the near point. This point is called the near point. Okay, so this near point is a point that is just 25 centimeter far from a healthy human eye. Okay, and least distance of distinct vision is what? This is a distance between the near point and the eye, that is of 25 centimeter. So the near point is a point and the least distance of distinct vision is a distance. This is the difference here. Okay, and This near point can be changed person to person, depends on the disease, what type of disease the person is having. The near point, as I'm telling you, this near point is what it can be more than 25 centimeter if the person is having whatever disease. Okay, but this distance will be same, that least distance of distinct vision, it will be 25 centimeter here. Okay, so it can increase with age, as it is said here, it can increase with age. So as the near point shifted, towards here, this side, so this distance also will increase. Okay, this distance is also will increase. So this is called the least distance of distinction, and this is the near point, and far point is at infinity for healthy human eye. Page number 190, question number 1. What is meant by power of accommodation of the eye? While explaining the structure of eye and its function, I have explained it, but you will see once again here as I am explaining the answer of this question. You will see that the ability of the eye lens to adjust its focal length with the help of ciliary muscles to see distant as well as nearby object, or the object at least distance of distinct vision, is called the power of accommodation of the eye. That means with the same eye, a human being is able to see the near object as well as the far object, and this accommodation of the power is called the power of accommodation of the eye. How it happen? So for that you will see that when the muscles are relaxed, which muscles? Ciliary muscles, which is holding the crystalline lens. If these muscles are relaxed, so that time the lens become thin. You will see here the lens become thin, and thus its focal length increases up to retina. So whatever object is there at far point, that means at infinity, that person is able to see that object because the image form in the retina, and because of this power of accommodation, this enable us to see distant object clearly. Okay, you can see here in the figure it is mentioned, you can see the distance here, and this distance is the distance of the lens from the retina, and it is large this time, and the focal length will be large because the focal length will be just fall on the retina because of the power of accommodation. Now what happen when the ciliary muscles contract? If any near object we have to see, so in that situation the ciliary muscles contract and the eye lens become thick here. You can see that the eye lens become thicker here. Okay, and consequently what happened, the focal length of this eye lens will be short, or you can say small here, that will decrease, and you can see that the retina is placed here only as it is placed here, but this time because of the thickening of the eye lens, this distance will be reduced, but this distance will be adjusted, so that adjusted as a focal length of this eye lens, so that the near object, it is the rays coming from the near object, is the images fall on the retina once again, and the person is able to see the object. You can see here the far object I have considered here, because the far object the rays are coming parallel, and it will meet here. Here also the near object, this time we have not taken the rays parallel because it is coming from the near object, but the same way the image will fall on the retina, but this distance you can see because of the thickening of the eye, this distance will reduce, and this will be the focal length of the eye lens. So this way you will find here the both the way means here the same with the same eye we are able to see the distant object and we are able to see the near object, and this accommodation is called the power of accommodation.